Okay, so if you know some basic algebra, hopefully you know what this symbol means right here because we are talking about functions, and functions is one of the most important topics in all of mathematics, especially algebra. So hopefully you recognize this notation and you know what a function is. But we have this function f of x is equal to 1 over x times the square root of x minus 2. And what we're trying to determine here is the domain of this function. Now, if you're saying, hey, Mr. YouTube Math Man, this just looks a little bit too complex for me, well, don't get too panicked because I'm going to do a quick review of what a function is, what the domain is, and then, of course, I'm going to walk through exactly how to solve this problem. But we do have a multiple choice question here, and let's take a look at our options. So A is x is equal to 2. B is x is less than 2, C, x is greater than 2, and D, the set of all real numbers. So which one of these is the domain of this function? Well, if you know the answer, put that into the comment section. I'll share the correct answer in just 1 second. Then, of course, I'm going to walk through step by step how to solve this problem. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoyed this content, make sure to like and subscribe, as that definitely helps me out. All right, so obviously you need to know what a function is to understand this question. But if you're like, I forget or I forgot all this, well, no worries. I'll go through what a function is and, of course, what the domain is and what the answer is. But let's take a look at the actual answer right now. So here it is. The correct answer is C. So C in our multiple choice options is x is greater than 2, but we need to be a bit more specific. So technically, we would kind of describe the domain of this function as x is greater than 2, where x is an element or a part of the real number set, or another fancy way to describe the domain is using something called interval notation, which would look like this. It would be parentheses 2, comma, positive infinity. Now, if you're saying, wow, this looks very sophisticated, well, it's not that difficult. But if you got this right, you definitely get a happy face, an A plus, a 100%, and a certificate of excellence for knowing a thing or two about functions and how to find their domains. This is absolutely critical for your knowledge in algebra. But let's go and go to the problem right now. So if you are a math student and you're like, I see a problem like this, I don't know what to do, I'm totally lost, I think I'm just going to skip the problem. Never ever do that, especially when you have a multiple choice question. Just take a guess. You're like, I don't know, I feel like D is a pretty lucky letter. So circle something, just don't leave the question blank. There's only one exception where you can should consider not guessing. Okay, and that's on exams like the SAT or ACT, where you do get some sort of penalty for the wrong answer. But even then, they generally don't take a full point off. It's like a quarter point or whatever the case might be. So, as a general rule of thumb, never ever leave a math question blank. But it's obviously better just to know how to do the math to solve the question. So the first thing we need to do is understand what a function is. Well, this is a huge topic in math, so I can't really go into the whole thing, but at least I can do some sort of basic review. Okay, now if you are studying functions, you need to really learn much more than what I'm going to be talking about in this little video, and I'll give you some specific suggestions on how you can learn more about functions. But in essence, a function is nothing more than a rule. Okay, so here is a rule. Now, what does this rule do? Well, the rule takes in some input values. Okay, it plugs in, it's like a machine, if you will. We're going to plug in some input values into this rule, and then we're going to get some output values from the result of plugging in some input values into this rule, okay, or this machine. Oftentimes, we like to describe a function as a machine, okay, kind of like a little thing like this. You throw some numbers in, and then you get some output numbers out. So that's effectively what a function is. So let's go ahead and talk about the input and output values of a function. So all the values that we can plug in to this machine and where the machine works, and we can actually generate some output values. And I'm kind of using very specific language here. You might be saying, well, hey, Mr. YouTube Math Man, are there some values that you cannot plug into a function? Well, yes, indeed. Sometimes there is. By the way, too, before I even continue, some of you might have observed with this problem that I should have said that we're talking about the domain of this function under the set of real numbers. So if you were thinking that, like, hey, Mr. YouTube Math Man, are we talking about the domain under the set of real numbers? Well, you get an A++. I'll get back to what I'm talking about here in a second because this is a very important detail. All right, so here is our function. We're going to plug in input values into it, and then we're going to get some output values. All the values that we can plug into this function is the domain. So the domain of a function is all the values that we are allowed to plug into the function. Think of it kind of like as a car. Okay, so here you have a car, and this car runs on, oh, I don't know, unleaded gasoline. Okay, so what can you plug in, or what can you fill this tank up in your car? Well, you want to fill it up with the right fuel, right? So unleaded. But if you go ahead and put diesel fuel in it, well, that's not going to be, really good for the car. So you can't plug in the wrong fuel into a function. I guess maybe that's one way to kind of think of the domain. The domain is all the values that we can plug into our machine and generate an output value. So this is a set of values. Okay, so the domain is not any one specific number. Sometimes it is, but most cases it's an entire set of values. Now, once we plug in the domain into a function, what's going to happen is we're going to generate a set of output values. Okay, and these output values is called the range. Okay, so we have the range of a function and the domain, and the range is dependent upon the values of the domain. So when we're talking about functions, sometimes you'll hear about independent variables, dependent variables, all this kind of good stuff. But for those of you that need to know more about functions, I will give you some recommendations. Okay, so here is an essence of what a function is, and what we're looking for in this particular problem is what values can we plug into this function? What is the domain of this function? So let's go ahead and take a look at a simple example of something that we're allowed to do in this function. So let's plug in 3. Okay, let's plug in 3 into our little simple machine here, our function machine. Now going back over here, f of x is equal to 1 over x minus 2. This x is, or it just represents a number. So whatever I plug in right here, so like I'm going to be plugging in f of 3 here in just 1 second, I'm going to replace these x's with 3. I'm going to do all the respective math here, and then I'm going to get my output value. Okay, so let's go ahead and find f of 3 of this function, and this is how I would state this. Okay, this is f of 3. This notation like this is f of x. That's how I would say it, f of x. So what I'm doing here is evaluating. This is the correct way to state this. We're going to evaluate this function for 3. So we want to find f of 3. So I'm going to write it this way. I'm going to be like, all right, I want to find f of 3. In other words, I want to throw 3 into my lovely function machine and see what the output value is. Okay, so that means I'm going to replace these x's with 3, just like this, and then do the simple math. So this is going to be 1 over 3 times the square root of 3 minus 2. 3 minus 2 is 1. The square root of 1 is 1. So down in the denominator, we're going to have 3 times 1, which of course is 3. So our final answer is 1/3. So f of 3 is 1/3. So that means that 3 is part of the domain of this function. Okay, so 3 is part, it's in the set of the domain, but we have many, many other numbers that we can plug into the function. Okay, and 1/3 is a part of the range or the output of this function. Okay, so this is a simple example of how a function works. Again, we're looking for all the values that we can plug in into the function. And the best way to describe that is basically to figure out what you can't plug into the function. Okay, so let's go ahead and talk about what you cannot plug into a function under the set of real numbers. Now that's a small little detail, but it's very important. So let's talk about the real number set. Okay, so here is our lovely real number line. So we have 0 right there. We have 1, 2, we have -1, -2 this way. So on this real number line, right, we have all the positive and negative integers, whole numbers, fractions, irrational numbers, etc., etc. So all the numbers on this number line is a set of real numbers. So what we're looking to figure out is out of all these numbers, what can we plug into this function? So some of you might be thinking, hey, Mr. YouTube Math Man, can I just plug in any number into this function and get a respective output value? Well, no, okay? Sometimes yes, but sometimes no. And here are the two restrictions that we need to think about. Okay, so the first is we can never have a situation where we end up with 0 in the denominator all by itself, okay? So if we plug in a real number, okay, into this function, and we end up with a situation like this, 1 over 0, well, whatever number that caused that cannot be as a part of the domain. So let me give you a simple example. If I had f of x is equal to 1 over x, and I said, I want to try to find f of 0, I would end up with 1 over 0. This condition is not allowed in the set of real numbers. Matter of fact, it's just not allowed in mathematics. So 0 cannot be a part of the domain. So we kind of have to get rid of 0. Okay, so we have to say, all right, well, 0 in this function caused a 0 in the denominator, so 0 cannot be a part of the domain. Okay, so that is a simple example there. So that's one condition we have to look out for. The next is a scenario where we end up with a negative underneath a square root. So we end up with like a negative square root of 3. Now, this type of number right here in math is what we call an imaginary number. It's under the set of complex numbers, okay, not the real number system. So the square root of negative 3 is not in the real number system. It's in the complex number system. So we cannot, when we're looking for the domain, and typically for most students, most math courses, I would say at the high school, basic college level, you're going to be studying domains or function domains under the set of real numbers. So you can't have a scenario where you're going to end up with a negative underneath a square root. Okay, so now that we know this, let's go ahead and put our knowledge together and figure out the answer to this problem. So the first thing that hopefully you can see is that we can't have f of 0, because if we had f of 0 right here, we would plug in a 0 for this x right here, and this 0, but this x would be 0 as well. But this, if this x was 0, 0 times this is going to be 0. This is going to cause a 0 in the denominator. So the first thing that we can state is that the domain x cannot be equal to 0. Now there's, we're kind of defining the domain as all the numbers that basically all the restrictions. Okay, so we'll kind of put this all together at the end of this video. I'll show you how to properly describe or the proper notation, excuse me, for the domain. But the first thing is here, x cannot be equal to 0. So 0 is not in the domain. Okay, so that is one obvious condition, but there is another situation, and that is we have a square root right here, right? So we have the square root of x minus 2. So x minus 2 cannot be negative, okay? So whatever x minus 2 is, it cannot be a negative value. So if it's not negative, then what can it be? Well, is it okay to have 0 underneath a square root? Yes, okay, because the square root of 0 is 0, but not in this case because we already said that it can't be 0. But if we had like, let me go ahead and show you a simple example. F of x is equal to the square root of x. Is f of 0 okay? Yes, f of 0 here would be okay because I would have the square root of 0. Okay, that's not a problem because 0 is not negative. Specifically, you're looking for negative values. So that means that our x minus 2 has to be what? Well, it has to be greater than or equal to actually 0. Okay, so that means it has to be positive. Okay, now here you might be saying, well, why did you have it as greater than 0? Well, we can't, if this was by itself, and this is where you have to be very careful. If I had this function f of x is equal to the square root of x minus 2, This thing underneath this square root could be 0, okay, for this function. But this function, it cannot be 0, so we already defined that. So if it can't be 0 and it can't be negative, well, that means it must be positive, right? So we can just set up a basic inequality. So x minus 2 must be greater than 0, i.e. it must be positive. So x minus 2 is greater than 0. We just solved this inequality. So we're going to add 2 to both sides of the inequality. We're going to get x is greater than 2. Okay, so that is our other condition, okay? So we have two conditions here for our domain, but we have to put this all together and describe the domain. But before we do that, I'm going to show you this real quick, which is an invitation to subscribe to my YouTube channel. I definitely need your help to reach as many people as I possibly can. You see, as a math teacher, I'm happiest when I have as many people as possible in my math classroom. But what I'm trying to do on my YouTube channel is really try to teach math in a clear and understandable manner. So it's pretty cool for me on YouTube because I can be less formal than I would have to be in, let's say, an actual classroom setting. But if you need help, okay, with functions, domain, range, this is a big, big topic. Well, do you want to check out my best math instruction? That would be in my math courses. So let me go ahead and tell you a little bit about my Math Academy. So you'll find links to all this information in the description of this video. But at TC Math Academy, I offer full, complete math courses. Okay, so for what we're talking about here, you might want to check out like my Algebra 1, Algebra 2, maybe even my pre-calculus course. Also, I have a ton of test prep courses. So if you're taking like the SAT, GED, maybe a teacher certification exam, check that stuff out. Also, I offer full and complete homeschool math courses. And if you need to review basic math, like the real basic stuff, check out my Math Foundations course. You'll find a link to it in the description below. And I'm talking about real basic stuff like fractions, place value, all that kind of good stuff. And if you just want to simply rebuild your math skills, check out my Math Skills Rebuilder course. I start with basic math, go through a ton of algebra, geometry, and even some trigonometry. Okay, so let's go ahead and get back to this problem. So we've done pretty good, at least to this point, right? So we figured out in terms of the input, all right, what can we put in? Okay, well, really what we did was figure out what we can't put in, all right? We can't plug in 0 into this function because that's going to cause a problem. And we know that this expression right here, the square root of x minus 2, x has to be greater than 2 because we need a positive value right there. So how do we properly define the domain? So pretty much we can plug in any number we want as long as it's not 0 and as long as it's not less than 2. So how do we define the domain? Well, there's a couple different ways you can do this. So let me go ahead and show you this right now. All right, so here is the domain. We are talking about the set of real numbers. A good kind of way to approach this is to draw a real number line. Now, as you practice, functions, domain, range, you'll pretty much have various questions on how to express the domain. But let's go ahead and just do a quick review. So here is our real number line. And what we have to do is basically we have to have all numbers greater than 2, which of course is going to exclude 0. Okay, so as long as we have a number that is greater than 2, not equal to 2, we can plug it into this function, no problem. Okay, so we can say the domain has to be all numbers x greater than 2, where x is an element of the real number system. So that's kind of the most technically correct way to express that. Also, there's something called interval notation, which looks like this. It's kind of fancy notation, but if you're taking a course like college algebra or pre-calculus, you need to understand this. This little parenthesis right here means an open circle. This means that we're leaving 2 alone. In other words, where 2 is not a part of the set of the domain. Okay, so in other words, we're not talking about 2, we're talking about all the numbers that are greater than 2. If we wanted to include 2, we would close that circle and make a little square bracket like this. Okay, but an open bracket means not 2, and we're going in the direction of positive infinity like so. All right, so 2 different ways you can define the domain of this function. And this is a critical, okay, and I mean critical topic in algebra and in mathematics. You got to understand functions. I just can't stress it enough. But if you're like, hey, Mr. YouTube Math Man, this seems to be too tough or too difficult for me, well, listen, I'm kind of jumping ahead. This is not the easiest of problems. So what you want to do is just find the right starting point for you and build up your knowledge from there. Okay, so with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.